HUDD is a toolset that automatically supports the identification of root causes for DNN errors. HUDD enables engineers to identify root causes by applying a clustering algorithm to heat maps capturing the relevance of every DNN neuron on the DNN outcome. The case study presented in this video is a head pose detection DNN that classifies the head direction of a face. To use our tool, you simply need to configure out the helper class with some information like the number of classes, the number of epochs, the case study name, the model name, and the DNN model to be used. Then, to debug your DNN model, you need to test outputs, and thus we require you to run the command to test the DNN model and generate the CSV files in the directory for the training set and the test set images. The analysis process starts with generating heat maps by running this command to generate heat maps for each file of the misclassified test set images, and then they are saved in the directory of the case study for each layer for each image. Heat maps are necessary to determine which images affect DNN results similarly. Heat maps capture the relevance of each neuron on the DNN results, and they are computed for each DNN layer. After having the heat maps generated, we run the following command to generate clusters by computing the distances between the generated heat map files, and then perform clustering by relying on hierarchical agglomerative clustering with word linkage to generate one set of clusters for each layer. Then for each layer, the optimal number of clusters is determined by identifying the knee point of the gradient of the weighted intra-cluster distance. Here I show an example of the distances computed, and as you can see, the distance between image 1 and image 2 is 1.6. However, such output doesn't need to be inspected by the end user, but can be used as an input by other research tools. What the end user inspect are the root cause clusters. Our root cause clusters help understanding the causes of DNN errors. This step is important because by inspecting each cluster, the end user decides the next step to take. For example, by simply retraining the DNN or increasing the training set or redefining the DNN by adding more classes. I'm going to show a few cases where first we can observe borderline cases where the person is looking between middle left and top left, so the head pose detection DNN often doesn't generate a correct result. The implication is that the engineer shall try to add more borderline cases to the training set. This is automated by the next step of HUDD. Next, in infrequent cases where the person is looking right but the eye are looking left, so the DNN might be fooled. The end user may decide to collect additional images like these ones or change the configuration of the simulator used to partially train the DNN to cover also for these cases. In our experiments, we have also seen other cases. For example, this is a cluster taken from another experiment where we classify the gaze direction of an eye, and as you can see, all the images are looking middle center, which was a class we forgot in the configuration of the DNN. The next step of HUDD is to automatically retrain the DNN. For that, we need an additional set of images. What happens is that HUDD selects a subset of images that are more useful for retraining. These are the images that are close to the ones in the root cause cluster. We perform bootstrap sampling to give to each cluster the same possibility to be improved. When the images are generated with the simulator, HUDD makes retraining more effective than simply selecting additional random images or filling images. When images are real-world images, HUDD saves cost because it indicates to engineers to label only the ones that are going to be used for retraining. Then we run the following command to assign images to each cluster based on their heat map distance. Then the assigned images will be exported to the directory, and as you can see, the images assigned to each cluster are very similar to the images in the original root cause cluster. And the next step is to run the retraining by running the following command. Finally, the DNN models of the retrained models will be saved in the directory for HUDD. Thank you for your attention. Please do not hesitate to download HUDD from this URL.